The James Webb Space Telescope, JWST, is a large infrared-optimized space telescope launched in 2021 by NASA in collaboration with the European and Canadian space agencies. Aside from being the largest, it is also the most powerful space telescope ever built. It is capable of observing some of the earliest galaxies in the universe and studying the formation of stars and planets. When the James Webb Space Telescope directed its highly sensitive instruments toward Pluto, the results far exceeded expectations. The images it returned were not only clearer than ever before, they were transformative. For years, Pluto remained a distant mystery cloaked in icy darkness. Even after NASA's New Horizons mission performed a historic flyby in 2015, many questions about the dwarf planet remained unanswered. Now, thanks to Webb's powerful infrared sensors and exceptional resolution, we are viewing Pluto with a clarity that was once unimaginable. The implications of this new data are profound. Pluto, formerly recognized as the ninth planet of our solar system, continues to fascinate scientists and space enthusiasts. Situated in the Kuiper Belt, over 3.6 billion miles from Earth, Pluto has always been a challenging object to study in detail. Earlier telescopes, including the legendary Hubble, could only capture blurry images of its surface. But the James Webb Space Telescope, with its 6.5 m gold-coated mirror and position beyond Earth's atmosphere, has revolutionized how we observe distant celestial bodies. Its precision in capturing light from far-off objects allowed it to reveal never-before-seen surface textures, atmospheric patterns, and geological features on Pluto. What makes Webb's accomplishment even more remarkable is its method of observation. Rather than detecting visible light, Webb operates primarily in the infrared spectrum. This enables it to detect heat and minute temperature variations that optical telescopes cannot see. When applied to Pluto, this capability has allowed researchers to look through its thin atmosphere and observe changes in surface ice as well as signs of potential geological activity. A recently released image from NASA and the European Space Agency highlights Pluto's complex terrain in unprecedented detail. The telescope has captured features such as nitrogen ice plains, mountainous areas, and possible seasonal shifts in the atmosphere. One of the most striking findings is the refined view of Sputnik Planitia, the heart-shaped region first imaged by New Horizons. Though this area was known to be primarily made of nitrogen ice, Webb's infrared view revealed depth, texture, and brightness variations that suggest active surface processes, possibly sublimation or deposition of ice, hinting at ongoing geological activity. Despite Pluto's remote and frigid nature, Webb's observations have also shed new light on Pluto's tenuous atmosphere composed mainly of nitrogen with traces of methane and carbon monoxide. While the atmosphere is thin and extremely cold, the infrared capabilities of Webb allow scientists to detect subtle temperature and compositional changes. This has enabled researchers to monitor atmospheric pressure and temperature over time, offering insight into Pluto's lengthy seasonal cycles that span its 248-year orbit around the Sun. In addition to Pluto itself, Webb has provided clearer views of its 5 known moons, especially Charon, the largest and closest, roughly half the diameter of Pluto and locked in a synchronous orbit. Charon has long intrigued scientists. Webb's instruments revealed more about its surface, including potential traces of frozen ammonia, complex hydrocarbons, and surface changes, suggesting a more dynamic geological past than previously thought. Webb has also imaged Pluto's smaller moons, Styxus, Nix, Kerberos, and Hydra, which have typically evaded close study due to their small size and great distance. With the telescope's precision, researchers can now better determine their orbits, estimate their surface makeup, and learn more about their origins. These findings are helping to piece together a more complete understanding of the Pluto system and the dynamic processes that shape the outer regions of our solar system. Perhaps one of the most intriguing outcomes of this new data is its potential impact on the ongoing debate over Pluto's planetary status. Though the International Astronomical Union reclassified Pluto as a dwarf planet in 2006, Webb's findings reveal a level of complexity, including layered geology, an atmosphere, and possible subsurface oceans that rivals what is typically expected of full-fledged planets. This challenges previous assumptions and reignites discussions about what defines a planet. Webb's high-resolution imaging. Infrared also highlights the scientific value of continuing to explore the Kuiper belt, where Pluto is just one of thousands of icy objects orbiting beyond Neptune. With Webb's clarity, scientists are now able to target similar bodies like EIS, make and hear with greater precision. Each observation contributes valuable data to our understanding of how the solar system formed and evolved over billions of years. Unlike Hubble, which focuses on visible and ultraviolet wavelengths, Webb's infrared technology allows it to peer through cosmic dust, detect faint heat sources, and reveal objects too cold or distant for previous telescopes. This is especially crucial when studying icy worlds like Pluto, which emit little visible light but stand out in infrared. Webb's success in imaging Pluto demonstrates the telescope's extraordinary capabilities. To capture such detail, Webb's guidance systems had to track a small, fast-moving object with remarkable accuracy, compensating for its own motion and Pluto's drift against the starry background. Conclusion. This achievement underscores Webb's adaptability. It can observe both the most ancient galaxies and dynamic nearby worlds within our own solar system. This versatility opens the door for future investigations of other distant bodies like Neptune's enigmatic moon Triton or other large Kuiper belt objects. With each observation, Webb is expanding our knowledge of these remote regions, areas still largely unexplored and full of potential discoveries. As scientists continue analyzing the new data on Pluto, fresh questions arise. Could there be a subsurface ocean beneath its icy crust, similar to those suspected on moons like Europa and Enceladus? What drives the apparent geological activity in such a cold and distant environment? Might cryovolcanoes be shaping the landscape and releasing volatile substances from below the surface? While Webb cannot answer all of these questions alone, it provides critical clues that guide future research and exploration. Another significant development is the opportunity for comparative planetology. Studying Pluto alongside other icy worlds to identify similarities and differences, scientists can now explore how Pluto's nitrogen cycle compares with Triton's, whether its organic compounds resemble those found on Titan, and whether Pluto's crust shows signs of ancient impacts or chaotic formation events. These comparisons deepen our understanding of planetary processes both within our solar system and in distant exoplanetary systems that Webb is also designed to study. Perhaps the most profound impact of Webb's observation of Pluto is symbolic. Not long ago, Pluto was little more than a blurry dot in even our most advanced telescopes, a mysterious, unreachable world. Today, thanks to Webb's extraordinary capabilities, we can see its rugged mountains, icy plains, and thin atmosphere. In astonishing clarity, we can trace the patterns in its heart-shaped region and witness the subtle movement of its moons. We can begin to unravel the story of this distant world. This progress reflects more than just advancements in planetary science. It stands as a testament to human curiosity and perseverance. Every image, every data set represents the work of countless scientists, engineers, and visionaries who dare to reach beyond the limits of what was previously thought possible. The detailed image of Pluto is a reminder that the universe has much to reveal if we have the determination and the tools to explore it. From Pluto's discovery in 1930 to the New Horizons flyby in 2015 and now to Webb's groundbreaking observations, the journey has been one of innovation and discovery. Webb's data not only enhances our view of Pluto, it also signals a new era in